Hello everyone. I'm here to introduce you some fascinating facts of trigonometry. Trigonometry? Yes, that very same chapter you enjoyed in your lower classes. Then, do you know what is new and amazing in it? The name of the chapter itself is new. It was trigonometric ratios that you did earlier, which was based on a right triangle. You learned about trigonometric ratios of one of the acute angles of a right triangle. But now what we are going to learn is trigonometric functions. Trigonometric functions we will be learning on angles more than 90 degrees. Angles more than 90 degrees. How is it possible? How can there be a right triangle with one angle more than 90 degree? As we know, when one angle is 90 degree, the sum of the other two angles should be another 90 degree to have the angle sum property true. So, in a right triangle, we cannot have any angle more than 90 degrees. That we know. But then, how to have trigonometry of angles more than 90 degree? Yes, that is the amazing thing about this new chapter, trigonometric functions. That is not the end. We will study angles more than 360 degrees and even negative angles. Negative angles. Wow. Is it really possible to have negative angles? Do we ever measure an angle in negative direction? Yes. With the help of a real life activity, let's try to understand the relevance and context of such angles first. Then we will be learning trigonometric functions of such angles. Something like sine of 750 degrees, tan of 1110 degrees, sine of 765 degrees, and even cosec negative angle minus 1410 degrees. Yes, let's go into this amazing trigonometric functions chapter. Here we have a screw which we want to insert on this board. And the screw is made in such a way that one full rotation of this screw makes its tip insert 2 cm on the board. That means if you rotate it like this, one full rotation, the screw will go in 2 cm. That means we can say to insert the tip 2 cm inside the board, 360 rotation is required. 360 degrees rotation. One full rotation means 360 degrees angle rotation. Now, if we are interested to insert it further, we need to rotate it further. One more rotation. One more rotation will make the screw going another 2 cm inside. Which means to insert the tip total 4 cm inside the board, we will have to rotate the angle 720 degree rotation is required. Now, in case we are interested to pull out the screw, we need to rotate it in the opposite direction. Rotate it like this. The screw will come out. That means to bring out the tip by 2 cm, 360 reverse rotation is required. Also, if you are interested to pull it further, 720 degrees reverse rotation is required for 4 cm to pull out. That means angles can be measured in one direction as well as in the opposite direction. If we call one of them positive angle, the other one we will call negative angle. This positive and negative signs are comparative. We can take one of the angles, one of the directions positive, then its reverse is considered negative in that example. So, the angles are measured by any real number. Any real number. Real numbers can be any number even more than 720 degrees. Real number means it can be a negative angle also. 360 degree reverse means minus 360 degrees we will say. So any real number. But these angles cannot be drawn as angles of right triangle, as we have already noticed. In a right triangle, besides the 90 degree angle, the other two angles should be less than 90 degree. We cannot draw them on right triangles. But we will study trigonometry. To study trigonometry of these angles, we take them in standard position. What is standard position? Angle in standard position. An angle drawn with vertex at the origin, having one of the arms taken along the positive direction of x-axis and the other arm taken in anti-clockwise direction is called angle in standard position. An angle drawn with its vertex at the origin, one arm along the positive direction of x-axis and the other arm taken in the anti-clockwise direction is called the angle in standard position. More angles in standard position. Using this definition, let me draw one angle. Yes, first angle, first arm. I'm taking on the positive direction of x-axis with the vertex at the origin of the Cartesian system, x-axis, y-axis. Now, 30 degrees I'm measuring in the anti-clockwise direction. Anti-clockwise means this is the angle anti-clockwise direction. Clock moves in this direction. This is clockwise. This is clockwise. Anti-clockwise is this one. So from this first arm, I'm measuring 30 degree towards that direction and you make the terminal side. This is called angle 30 degrees in standard position. Angle 45 degree in standard position. Initial arm should be the same. Vertex should be the same. But the measure in the anti-clockwise direction, little more. 45 degree in standard position will look like this. 60 degree in standard position will look like this. 90 degree in standard position. 120 degree in standard position, that's going more than 90 degree. So more than 90 degree angle will be drawn like this. Go further in the anti-clockwise direction. From the initial arm, go 120 degrees. You draw the terminal side there. This is the angle in 120 degree in standard position. 135 degree in standard position. 180 degrees in standard position. From here to here. 225 degrees in standard position. It's going beyond 180. Yes. 270 degrees in standard position. 300 degree in standard position. 330 degree in standard position. Now if we organize those angles which we discussed now all together, it will look like this. This is 30 degree in standard position as we have already seen. Now 45 degree will be little further from here to here. Then 60 degrees, 90 degrees, 120 degree, 135 degree, 150 degree, 180 degrees, 210 degrees, 225 degrees, 240 degrees, 270 degrees, 300 degrees, 315 degrees, 330 degrees and one full rotation makes it 360 degrees. Now the question is, can there be angles more than 360? Yes, we have already noticed. But now, how do we draw angles more than 360 degrees in standard position? Here we go. This is simple 30 degree in standard position. But in case we want to draw an angle 390 degree, this is how we manage. That is 390 is one full rotation 360 and 30 further. 360 and 30 more. 360 plus 30 is 390 degrees. So we notice here one thing. Angle 30 degree and angle 390 degree, they have same terminal side. Initial side is anyway same for all angles in standard position. But the terminal sides were all different. But Once angle 360 degree over, the more angles will start getting same terminal sides. So 330 degree and 390 degree, both of them are called coterminal angles. Angles having same terminal sides are called coterminal angles. Now let's see how we draw negative angles in standard position. Here we have all of these positive angles in standard position that we already did. Now 30 degree in negative and negative 30 degree in standard position will be drawn to clockwise direction. If plus 30 is that side, minus 30 is to clockwise direction. Minus 45 degree will look like this. Clockwise direction 45 degree is minus 45 degree. Minus 60 degree, minus 90 degree. Plus 90 degree is this, minus 90 degrees here. Minus 120 degrees. Minus 135 degrees. Minus 180 degrees. Here we notice one thing. Plus 180 degree and minus 180 degree are coterminal angles having same terminal side. Minus 225 degrees. Minus 225 from here to here. Minus 270 degrees from here till here. Can you say what would be the coterminal positive angle for minus 270? Yes, plus 90 degree. Plus 90 is from here to here, this. Anti-clockwise 90 is positive 90 and minus 270 is from here to here. Both of them are having same terminal side. Minus 300 degree, minus 330 degree, minus 360 degrees. Now, as we have come to know how to draw the standard position angles in negative direction as well as more than 360 degrees, we are in a position to define now trigonometric functions. Next is trigonometric functions defined for any real number